Hello there, geometry peeps. Today we have we're going to do a similarity application type deal with the overlapping triangles, and we're also going to introduce this concept of geometric mean. All right, now think back of what the mean means when we speak arithmetic mean, the mean, median, and mode. Back in algebra, your teacher might have asked you to find the mean of some scores, and what it is it's just an average. Well, in geometry, we have a mean proportional or geometric mean, and it's a proportion that contains what we call extremes and means. So extremes over mean equals mean over extremes, and all these are our numbers, and we just label them extremes and means. Alright, notice the mean is in the middle if you want to think about it that way, similar to an average. So if I ask you to find the geometric mean between the two numbers 2 and 18, what happened is I've given you the extremes and I'm asking you to find the means. So for the extremes, we're going to call the extremes 2 and 18, and we're going to call the means x. Alright, and what we want to do is solve for that x value. So when we cross multiply, I get x squared equals 36, square root both sides, and x is 6. Alright, now, another way to think about this is if you had to think of a rectangle, and it was 2 by 18, the area of this rectangle would be 2 times 18, which was 36. So if I found the geometric mean to be 6, I could create the area of a 6 by 6 square, and it would have the same area. Alright, so the geometric mean would produce the same area using numbers that satisfy our proportion. Alright, so just a quick piece of information that we're going to bring back a little later in this lesson. Alright, so that's what that is. Now, theorem. Our first theorem for today says, if you draw an altitude to the hypotenuse of a right triangle, it forms two triangles that are similar to each other and similar to the original triangle. Say what? Alright, so we have, if you draw an altitude to the hypotenuse of a right triangle. So if this is my right triangle called ABC, and I draw an altitude to my hypotenuse, so what I'm doing is I'm drawing a third line, a second line, and I'm going to call that point D, and what I've done is draw an altitude. If you remember, an altitude creates a 90 degrees. So I drew an altitude from the 90-degree angle, and that's the important piece, to the hypotenuse from the 90-degree angle. What this does is it creates three similar triangles. Alright, let me explain how. The first triangle we have is ACB. So that's the big triangle. So that's the big triangle, ACB. And then by drawing in that black line, we've created two little triangles. We have, that's ugly. We have ACD. So the right triangle on the left, ACD. And we have the triangle on the right with my right angle here, and this is CDB. Alright, now what this says is, what the theorem says is ACB is similar to ADC, which is similar to CDB. Now, I wrote those in order a special way, and I'm going to explain how in a minute here. If you notice my right angles, C's a right angle, D's a right angle, D's a right angle. They're all in the same spot, C, D, D. So all my right angles match, so that's one angle. Now let's look at this. In this big triangle, I have angle A. Now angle A matches up with this angle in this triangle because it's actually the same angle. Whether I'm drawing the big triangle or the little triangle, angle A is the same angle. So these two we can say are similar by angle-angle. Alright, our angle-angle similarity. Now the same occurs here. Let's look at this first one. C and D match up. Now I want to look at angle B. Angle B, let's use a different color here. Angle B is the same here, and here, regardless if I draw my big triangle, angle B, or my little triangle, angle B. So my big triangle and this one are also similar as well by angle, angle. And because those two are similar and these two are similar, by default, these two are also similar. Okay, now, matching up the big one with these little guys is easy, because the right angles match up and A is the same. Here, my right angles match up and B is the same, but you have to be careful. When matching up these two, you have to pay close attention to the order of the letters, because AD matches up with CD. And notice how that's a little flip-flopped. It doesn't make as much sense, but that's how it works. Alright, and if you notice, my C's are not congruent. Alright, C matches up with B, and A matches up with C. That's because look how this is cut. This isn't cut split in half 45-45. It's cut differently, so you have to be careful because our C's aren't always the same. Alright, so let's apply this to a few examples now. So the first piece is you have to decide which triangles to use. Well, we need to solve for x, so it looks like it contains this little triangle. Whenever you have a number in the middle there, you're going to have to use the little triangles, because if it was the big triangle, that 8's not contained. So we have triangle CDA with my right angle being at D, AD being x, CD being 8, and then over here I have CDB with CD being 8 and DB being 4. Now this isn't like congruent triangles where CD is reflexive, because it might have not have grown at that rate. So up here, let's match it to our two statements here, ADC and CDB. So now I know I have triangle ADC is similar to triangle CDB. Let's check. Our D's match up, and we're good to go. Our C's don't match up, because that one's bigger than that one. So when we set this up, we have AD, which is x, and AD matches up with CD. So x over 8 equals CD, and CD matches up with DB, 8 over 4. Now, I want you to notice something. Notice my 8's match, similar to what we did at the beginning to our geometric mean. So, when I cross multiply and solve, I get 4x equals 64. So we divide by 4, and x equals 16. And that's what we want you to do, is find x, solve for x. Okay, so it's taking what we know about similar triangles and angle, and creating miniature triangles, or the big one, using all three triangles to solve for a problem. So it takes some application and some thinking. Alright, now let's go down here. Now notice, deciding which ones to use, it looks like we're going to have to use this one on the right, and then they give me this big 8, so it looks like we're going to have to use the big one as well. So let's draw the big triangle. There's my right angle, CBA. And we know AB is 8 and CB is x. And then we're looking at this little triangle on the right here, CDB, with CB being x and DB being 2. And always try to write a similarity statement. So we have, let's go off the cusp this time. Let's not refer to up above, just in case we don't always have the same letters. So triangle CAB is similar to, well, C is my right angle, and my right angle matches up with my other 90-degree angle, which is D. A, well, we know B uses itself, all right? In this case, B is itself. So B is going to match up with B, so that means A is going to match up with C. All right, so now that I have my statement, let's set it up. I got 8, so AB and CB, 8 over x equals x, CB matches up with DB over 2. Again, something's matching. So I have x squared equals 16, When you square root, you get 4, plus or minus 4, but in this case, we're representing a side length, so it has to be positive. Alright, that's all I got. See ya.